Hello, dear fellows humans. I'm going to talk about necessary and sufficiency. Necessary and sufficient. Okay, the relationship between two things can have two relations. One of necessity is necessary, and another is sufficient. The first one is necessary and sufficient. What deterministic ways is called cause and effect. In order to, if you drop something, this will fall, okay? And the cause is the attraction, and the effect is the fall. As a matter of fact, it's not like this, but let's forget about the relativity for a moment. And the second concept is when you have a relation that is necessary, but it's not sufficient. And this relation was originally called by Edward Singer in his book Images and Reflection. And he gave the following example. If you have an acorn, the seed of an oak tree, it is necessary for the growth of an oak tree, okay? But it's not sufficient, okay? The sufficiency can be provided by cofactors like good soil, water, sun, protection, and so on. Okay? Therefore, the sufficiency is provided by cofactors. And then we add right now is that this cofactor could be provided by a decision maker. And therefore, the decision making is providing the sufficiency. Okay? And the decision maker is doing this to maximize his utility. For the utility is a sufficient relation to have someone to do something. Third relation that I call deistic is not necessary, but is sufficient. Okay. Therefore, like God, is not necessary for the things, but is sufficient for the thing. Okay. And to complete the taxonomy, we will have a fourth relation that's not necessary and neither sufficient, that we call accidental. Okay? Whatever happens in one place doesn't necessarily has to do with what happens in another place. Is neither necessary nor sufficient. It's just accidental. Okay, but all this for relationship could be also probabilistic. Uh, Before going to the probabilistic, let's explain a little bit more. The necessary and sufficient is the just normal physics and all the things, okay? All the normal physics, the deterministic one. And if you go to the probabilistic physics, go to quantum theory and things like that, okay? It's more probabilistic, okay? It's the same stuff, but one is deterministic and the other is probabilistic, okay? Okay. Now, when dealing with necessary but not sufficient, in the case of necessary and sufficient, you can predict things as they will. If it's a determined thing, you will predict. If you have the initial condition, you can predict what will be the final condition, okay? Where the planet will be, where the earth, where the sun, things like that, okay? And if you are in an environment that's probabilistic, you also can predict things, but in a probabilistic way, okay? Like in the some experiments of an electron going through two slits, okay? When you have one slit, you think that is just a deterministic thing, but when you have two slits, you see the behavior of the electron in a probabilistic way, like a wave, not only as a matter, but also as a wave, okay? Therefore, it's probabilistic. Now let's concern us a little bit more with the accidental method. There is not much that you can do, okay? One relation has nothing to do with the other relations. One happening has nothing to do with the other happening, okay? And the deistic relationship is interesting to discuss, but not of all it in theological terms, okay? But in employing utility function, welfare function, things like that, because they have this kind of behavior. They are not necessary, but they are sufficient to explain how the things behave, how the person and how the people or society behave. Now let's deal a little bit more with the necessary but not sufficient relationship. This is interesting because it's one of the more interesting things that there are. The real social, psychological, all the kind of interesting problems, okay? like, as I said already, the necessary thing is that things have to behave a certain way. But why they behave this or that is can be provided by another relationship that's not necessary but is sufficient, like the utility function. Okay, let's be more explicit. I keep applying in my research, as I apply in my PhD dissertation. I applied the necessity by employing a function that describes the system, and the sufficient I provide by attaching to it a utility function. Okay. I apply this to transportation model. The utility function was kind of demand function, and was based on theory of perception. Okay, like theory of perception, the first law of psychophysics says that the perception is equal to the stimulus raised to a power alpha. Okay, therefore all the perceptions are usually not a function, a linear function of the stimulus. Okay, like if I pinch myself, the pinching that I'm doing is pressure. It's related to the area. Okay, and in order to feel the double pinch, twice the pinch, I have to increase by the force 4 times. Okay. Same thing with light. As a matter of fact, we live in a world of perceptions. There are no realities in this world. We only have perception. The real thing is a fiction of imagination. What we have is a visual perception, olfactive perception, a gustative perception, hearing perception, a touching perception, okay, and other perceptions that you have. Therefore, we live in a world of perception, in a universe of perception. When I say, oh, I am holding myself, no, it's just a static feeling of touching. Okay? It's a perception. The real thing, me, Ferruccio Bilic, I'm touching my face. No, it's just a visual, a feeling. I am seeing myself. No, I'm seeing an image of me. The real me, I don't know. Who knows the real me? Okay? If I lick myself, is a tasting perception. If I smell myself, it's a olfactive perception. If I hear myself, it's a hearing perception. Okay? Therefore, we live in a world, in a universe of perceptions. There are no realities, they are only perceptions. Okay? And we can forget about reality. We can live in this world of perceptions. Okay? But perception can be misleading, can be manipulated. Okay, the whole idea of marketing is to manipulate our perceptions. Let's give some example for you to tell you how you are manipulated all the time. Like when you are in an elevator, you are manipulated. Your perception of size of the elevator usually is manipulated. Why? Because almost all the elevators have a mirror inside it. Okay? Why? Because the mirror is manipulating your perception of space. You imagine, you look at the mirror and your perception is that this place is twice as big. Okay? Therefore, it's a little box that your perception is manipulated so that you don't perceive that it's just a little box. Therefore, your perceptions of size is manipulated. But not only this, because it's a mirror. You also watch yourself, how your hair is, how you are, how you look good, and you don't perceive how much time the travel in the elevator takes. Therefore, you are being manipulated a second time, not perceiving that the travel time in the elevator is high, and you perceive it as not that high because you were busy in your admiring yourself. Okay? As a matter of fact, all the presentations deals with this subject. You can see how pleasant or unpleasant is a presentation if you are asked how long has been this presentation. And if you say it is 19 minutes, you are close on the mark. If you think that is just 10 minutes, means that you are loving the presentation and very interesting. Therefore, the perceived time is less than the real time. But if you say that, boy, it's more than 30 minutes, then your perceived time is higher than your real time. Therefore, you think that it's boring, the presentation. Okay? Therefore, we live in a world of perceptions. And comfort is a perception. Time is a perception. uh, even the time that is perceived by the watch is a perception. That's a deep thought, but you think about it. It's homework for you to think about. Uh, and because we live in a world of perception, and the and we can also see that there is a lot of things affecting our perception. Okay, not only comfort, time, cost, and all kind of perception. Therefore, our demand function, that is correspond to our the kind of utility function, is should be exponential function. Okay, that's why we associate to it where we apply a logic model when we are estimating this function. Okay, because you observe the time, you observe the distance, you observe the cost, and how they affect your demand is a logistical matter, because none of this is linear. Okay? In other words, there are no straight lines in this universe. Forget about straight line. There are always some curves. Okay? It's a deep thought also. Think about as a homework. But if we have necessary and not sufficient, we can have a description of the situation that can be also probabilistic, okay? Like I use in my transportation model, I use a Lagrangian function, but employing also entropy maximized technique. What does this mean? That based on initial statistical distribution, original one, simple one, I introduce data, even with the attached to it demand function, and I derive posterior distribution, okay, that describes the transportation phenomena, taking in consideration this information. Therefore, was a model that encompasses a condition of necessity and of sufficiency. Okay, even it was probabilistic and describes and explains well the phenomena. And most of the time, in mathematical analysis and programming, I used to employ this thing. Another thing that I did also was, instead of using distribution function that you want to maximize or minimize, whatever, In this case, you want to maximize, because you want to maximize the entropy and you want to maximize the utility. And you would have some constraint. But all the information that usually other people put in the constraint, I devise a way of putting all this information in a better form as weighting coefficients in the objective function. Okay. The problem with constraints is that if they are not binding, okay, and therefore the constraint doesn't work up to a point when get to the constraint goes to infinity. That's not realistic. Then I add to the objective function the information that describes the data in this constraint as a function that goes up gets close to the constraint. Okay, then therefore it's a better model, it's a more real model, close to reality, and fits better the system. Okay, and the deistic aspect is provided by the utility function. Okay. I guess that I put a lot of ideas in this thing, but this is a difficult topic. Just another thing. All these things also are related to quantum field theory, okay? Because all the cofactors that act in the system, they all act in the system as several fields, force or energy or whatever. Okay? Therefore, the original idea of all this thing comes from quantum field theory. The idea that I had when I was about 19 years old, and I keep developing, and I hope that I complete developing before I die, okay? But that's why, that's what I have to tell you today. But if you have any question, I will be happy to answer them, okay? And thank you for your attention, and I hope that you profit from some from these thoughts. Thank you very much.